Hello, everybody. Now we're going to do our uh, problem finding the center of mass of the system where we have four particles of each one is mass m. So we know that in order to find it, we're going to have to find it in on the x-axis and on the y-axis. Now I'm writing capital X and Y because I'm talking about the position of the center of mass. So let me just write it better. On the x-axis, well, before we do the calculation, let's look at it logically. We have a uh, parallelism along the y-axis. Along the y-axis, we have a parallelism. So it means that everything we have on this side, we have on this side, same mass, same distance from the uh, y-axis. That means that our center of mass will be along our y. Sorry. Okay, so our center of mass will be on the y-axis. So when x is equal to 0. So let's find out, first of all. We know that it's equals to 1, oops, 1 over capital M, and the sum of the mass J times the distance J from I from I to 1, 2. How many particles we have? 4. So our M is equals to the sum of all the masses, so I is equals to 1 to 4, which is then just simply equals to 4m, because every single mass is equals to m. And so we can just substitute it 1 over 4m, and then the sum of all this. Well, in this case, we're talking about, instead of r, we're talking about the x value of this. Um, so the first mass, we're going to take this mass over here. It's going to be equals to, well, the mass of this particle will be equals to m, and the distance from the center of the x-axis will be equals to a over 2. So times a over 2. Plus, well, then we're going to look at this mass right here. Mass is equals to m, and then the distance from the y-axis is equals to a over 2. Oops. Okay. Then plus, we're going to look at this mass over here. So we're going to have a mass of m, and the distance from the center axis is going to be equals to actually negative a over 2, because it's on the negative side of the x-axis. And the last mass, which is equals to this one, is going to be equals to m times negative a over 2, because again, it's on this negative side. So if we add all this together, we actually see that we all cancel these out, and in fact, we get a 0 as an answer, and that is the y value of this. All right, so let's look at the y value now. Well, let's look at this first of all logically. We know that we have a parallelism. We have like a sort of mirror along this line that I drew. Let me just actually draw a concrete line over this line, because if we were to mirror everything on this line, we would see that there is something on the other side, perfectly the same distance, same mass. So we know that it's actually going to be along this axis. Then we can say it's going to be equals to half of a, because as you can see, it's going to be half of a. Now let's check it mathematically. So we're going to have, again, same formula right here. The only thing that changes is that instead of the x, we're going to have the y. So it's going to equal to, again, 1 over 4m times, well, okay, so this part over here is equals to m times, what is the distance from the x-axis? It's going to be equals to 0, or the value of this position on the y-axis, 0, plus the position of, plus this mass over here, we'll cancel everything else, okay, plus m times, in this case, the distance is a, so plus, next one, oops, is going to be equals to m times a, plus the last one is going to be equals to, again, m times 0. M times 0. And if we solve all this, we're going to get 1 over 4m times 2ma. So we can simplify this 4 with this 2, this m with this m, and we're going to get our answer is going to be equals to 1 over 2a on the on the y-axis. So our center of mass position is gonna be on the it's gonna have coordinates 0, comma a over 2, and that is a solution to our problem. Oops. Okay, doesn't want to feel it. There we go.